Chapter 4, Section 5, How to handle missing data. In the previous section, we explored how to find missing data and types of missing data. A dataset often contains missing data. When you find missing values in a dataset, you might want to delete rows and columns that contain missing data as useless. Deleting rows and columns that contain missing data is one of the ways to deal with missing data, but there are other ways. In this section, we will discuss some basic principles on how to handle missing data. As a basic principle, it is important to retain as much data as possible when missing values exist. If you delete rows and columns because there are missing values, the number of samples and features will decrease, and the information necessary for training the prediction model may be insufficient. Moreover, if there are some patterns in the occurrence of missing values, deletion can make it impossible for a prediction model to consider those patterns. Therefore, we should prioritize using methods to impute missing values with estimated values, or use algorithms that can analyze data that includes missing values. You may feel strange about imputing missing values with estimated values, but predictive analytics aims not to describe the data perfectly, but to accurately predict future results. For this reason, it is more important to discover the patterns hidden in the data as a whole than to ensure the accuracy of each piece of data. To find these patterns, it may be more effective to fill in missing values and retain data that is not perfectly accurate, but close to the actual data, rather than delete data to reduce the amount of information due to missing values. Therefore, the basic approach to missing value processing in predictive analytics is first to consider impute missing values with estimated value, or use algorithms that can analyze data with missing values. In cases where these methods are not possible or not appropriate, then consider deleting data. For imputing missing values, the simplest method is to use representative values such as the mean or median. Another common method is to use predictive models to estimate values for missing data. Linear regression or k-nearest neighbors are commonly used as predictive models for missing data imputation. However, since these estimated values are just estimation results, they may differ from the actual values. Therefore, while imputing with estimated values may improve the prediction accuracy in some cases, this is not always the case. In addition, it is necessary to select an appropriate imputation method according to the mechanisms of missing data occurrence. A mechanism of missing data occurrence will be explained in the next section. Instead of manually imputing missing values, we can use algorithms that can analyze data that include missing values. Algorithms like XGBoost, Random Forest, and LightGBM can analyze data and develop prediction models even if the data includes missing values, without imputing or deleting them. If there are missing values in respondents' age data, these algorithms use the missing itself as information. That is, this person's age is unknown. Specifically, these algorithms separate respondents with unknown ages into a specific group and automatically learn patterns related to them. By doing so, these algorithms can make better decisions by ignoring missing values. Deleting rows or columns containing missing data is a last resort when other methods are unavailable. The simplest method is to delete all rows and columns that contain missing data, but this can result in a significant loss of information in the dataset. It is recommended that you return to the basic principle of keeping as much data as possible and delete rows and columns that do not significantly reduce the amount of information. The following situations are cases where deleting rows or columns will not significantly reduce the amount of information. Rows that contain many missing values. Columns that contain many missing values. Rows or columns that contain missing data account for only a small proportion of the total data. So, why is it okay to delete rows with many missing values? Rows containing observed data for only a few variables do not have sufficient information for a prediction model to learn the relationship between the variables. Such rows can become noise, and the prediction model may not be able to learn meaningful patterns. Now, let me explain why we can delete columns with many missing values. If a column with many missing values is not so impactful on the outcome, we can delete it. A column with many missing values does not have sufficient samples for that variable. Therefore, the information stored in that column may not represent all the data. Analysis that uses non-representative data may increase the risk of introducing bias. And once again, be careful not to delete variables that are likely to significantly impact the value you want to predict. If the number of samples with missing values is small compared to the total number of samples, deleting them will have little impact on the model's prediction performance. Deleting samples with missing data may be an appropriate option in this case. Deleting them will simplify data preprocessing and eliminate the need for missing data imputation, making it more efficient to train and predict a model. However, when deleting data with missing values, we should be careful if the missing values do not occur at random, but follow some pattern. For example, suppose a case where there are many missing values in the male sample, but only a few in the female sample. In such cases, deleting the missing data may introduce bias into the model because the model put too much weight on female samples. Also, if a variable with missing data strongly affects the prediction results, ignoring it may significantly reduce the model's prediction performance. For this reason, even in cases where data deletion is highly likely acceptable, we should first consider methods other than deleting data. Thank you for watching. Please thumbs up and subscribe to my channel.